Hey friends, today we're talking about FIFOs, and I just wanted to show you something uh, pretty quick that might be useful for you. So, really quickly, FIFOs are kind of an obscure thing in the Linux and Unix world. They stand for first in, first out, and another name for them is named pipes. And so they're basically these things that live on your file system, and you may have seen them before and kind of wondered what they are. And they're called FIFOs or named pipes. And here's what they let you do. You can you can do stuff like you can do stuff like cat my FIFO. And then from another process, totally separate process, you can write into. Okay, that was weird. I had two things catting the FIFO. So you can write into the FIFO. Okay, so what just happened there is I have one command that is listening on the FIFO, and then I have another command that writes a message through the FIFO and is received by the other side. What you'll notice is that if I try to write without a listener on the other side, the writer blocks until the listener receives the message. So that's kind of the basic operation of the FIFO. But it's kind of nifty because it allows you to send data from one process to another process without having the two processes being related in a parent-child relationship like you normally do with pipes, where a process forks a child and then they can share a pipe and send data. In this context, you can just share data between two arbitrary processes on your system, and it's a little bit simpler to use than something like sockets, like Unix domain sockets, which are another viable solution for this. Of course, there are pros and cons and trade-offs, but FIFOs can be a nice little tool to be aware of. So one thing you can do is you can have like these little loops. For example, you could have one reader just on the end. Oops, I typed that wrong. Done. You can have one reader on the end, and then now you can just have writers just writing into it, and then you can see that on the other side. All right, so now here's an actual use for them that I was kind of getting into today. So let's say you just have a program that generates a lot of terminal output and kind of spews into your terminal. But also the program has a bit of some edge cases and maybe some maybe warning conditions or places in your code where you want to log a diagnostic message for debugging. You could just do a normal print in your code, but then that print would get interspersed with the actual output of the program, and you may not want that. So the typical solution is to then write your diagnostics to the standard error stream and your real data to standard out. And of course, this works pretty well, but as an exercise, we can try to use a FIFO for this. So have the data going to the standard out, but then write our diagnostics actually to a FIFO and to basically a different process. And this could be a bit nicer than trying to, for example, like write the data to a file on disk. Maybe you don't want to do that, or maybe that's a bit wasteful and just to touch disk for this kind of diagnostic logging kind of thing. Maybe you don't care about having those messages on disk and taking up disk space. So writing to a FIFO is a nice way to keep it all in memory. And here's what that would look like. I'll just make the text a little bit bigger. So I am just sketching this out in Python, but let's say we have our simple program that just prints out numbers one after the other and increments them. And then on multiples of 5, it is wanting to log a message. Here we are instead of doing a print command, we're calling our log function. And all our log function does is it takes this FIFO that was opened up earlier in write mode, writes a message to it, followed by a new line, and then flushes that file object or file descriptor. Let's just try this. So what we can do now is bring up our trusty logging bash loop, which will wait, and then we can run our writer, and it's going to go ahead and increment all these through all these numbers, and we can see that our log messages come in nice and cleanly on the other side in this other process, entirely in memory, no touching disk here, and it's just a nice separation of the two. So we can have our long-running process that just spews a ton of output, while also keeping track of our diagnostics in a bit more of a clean separation. Lastly, we can take this one step further. And so, like I mentioned, it's a little bit more clean and semantic, like Unix semantically correct to log to standard error for this kind of thing, rather than, I mean, I wouldn't actually totally recommend doing this FIFO thing in real production code. It's more of a debugging thing or kind of a one-off thing if you're in a bind and you need to get some data outside to another process and you don't want to use any of the standard file streams. You can use this, but to be a bit more semantically correct, you're probably not going to want to hard code in like logging to a FIFO necessarily. But for this use case, probably standard error is a good way to do this. And we can have the best of both worlds because we can log to standard error, which doesn't require any of this weird FIFO stuff. But then when we invoke the program, we can redirect standard error out into the FIFO, which has all of the same benefits. So let's try this. This is the writer2 program, and it's doing the same thing, just incrementing an integer, printing it out, and then if it's a multiple of 5, printing this to standard error. And this has one obvious advantage of that you can run the program, and if you don't have the listener running, the program's not going to block. Because if we ran the first one, it doesn't go anywhere because it blocks on that write to the FIFO because nothing is listening. So that is not ideal. But on the other hand, if we have this second one, we have kind of like a kind of nice program, you know, it's the output is interleaved, but at least the program runs. And then if we want to, we can set up our listener, and we can choose to redirect. We choose to redirect the standard out or standard error only into the FIFO. That's what this to thing does. If we didn't have the to, only the standard output would be directed into the FIFO, which is not what we want. It's kind of the opposite of what we want. But we can choose to redirect only the standard error. And this achieves the exact same thing. We get our nice clean output on the left, and then we have our nice clean diagnostics in a separate pane, terminal pane, separate process. And you can do whatever you want over here. If you want to also actually record these diagnostics to a file, you can absolutely do that. You might, I've actually not tested this, but you might be able to tee it to a file. And so let's just experiment with this live on the fly right now. And so teeing is going to be printing to both the standard output and to and writing to the file. And so I guess I'm in the way here, but you can see that we are simultaneously logging and also writing to a file in case we cared about that. So once we're in this separate process, we can do whatever we want with the logs. We've avoided touching disk on the way from the actual writer process into the diagnostic process, but then we can do whatever we want, including touch disk or not. So that That's honestly all I know about FIFOs. They're an interesting, obscure tool, and here is just one application that I thought of that might be useful for your bag of tricks.